Yeah, I'm glad to be here, and thanks for Tanya. She asked and convinced me that I could come. And I want to talk about something which is a little bit out of the field where we normally are in, is about the communication transfer of modifier standards. Assessing as an example, I take the assessing of thermal effects for urban areas. And this is a joint presentation from myself, HEINKE SCHLUNZEN, University of Hamburg, and Katharina Fröhling, Julianike Kuhn, Gusheng, and Andreas Putz from the Association of German Engineers. So, first, I want to give you a simple example where we all have now questions. You might already concentrate on the right-hand figure and get your conclusions what it is. And then a little bit about general aspects of communication, ways of knowledge transfer in science, and assessment of thermal effects in urban areas. 3 examples from standards we have and the engineering association which we provide, and draw some conclusions. So in the meantime, you made your decisions what it is, and you probably assumed it's something of an Canterbury or urban heat island, and it's predominantly calculated for 2 sites. In this case, for whatever you are interested, for Black Bounty and Fullspotter, it's probably nighttime values because you see the moon. It's an annual cycle because in the meantime you have seen it from January to December, and it's probably because you know how it's done, a deviation from somewhere, maybe a Moore site. So what is up here is there's a Moore site, and we all know that the urban heat island intensity depends on the selection of the Moore site, not only from the urban side. And is it inside or outside the urban area? Is it maybe an apartment in the urban area? Is it downband or upband of the urban area? Average nighttime values used, and in this case, what is nighttime? Or extreme values compared. What is the averaging time for these months? Is it just 1 value per month, or is it 30 years of data? So I think what is important for this is really a tiny example, which we present all the time, also to each other. It's important to communicate where the signs are, what their characteristics are, what the averaging, because the averaging reduces intensities, so also if it is an average value or not. And I think if you communicate that, I've seen that in many talks these days, that people just didn't say really if it's surface urban heat island or atmospheric urban heat island, so Canterbury urban heat island. So providing the details that we need to understand even each other to use that assessment, and also to convince for instance, urban planners what to do. If we are not clear ourselves, we can't convince anyone. And we did at the WMO this common Canterbury urban heat island, and several. So, for instance, Alberto was also a co-author there, so several were involved there, like 30 co-authors, and there you can see a lot of details from this. And it's important to do that, because we all have different understandings of the same information. And this is my next part, therefore. I think you all should and will know that, but I tend to repeat that in recent days more and more, the general aspects of communication. What we think is we say something, as I say something to you, that's a message, that's a medium for communication, in this case, my language and your ears. You receive it, and then you think, now you know. I'm sure you don't know, and you understood all something different than I have said. Because in reality, it's not going direct ways. I give you some facts and show something from myself. We have a relationship to each other. I tell you, do it this or that way. And I still talk to you. but you are living in your own world. You maintain context, how you take this. And if I say don't do this, then you feel me like a small child and you will not follow me anymore. Or you think I should follow that person because she now is so intensive. The formulation is relevant, my body movements, my tone of voice, and in the end, you get something completely different. This is not a misfitting. The message might, in the end, be something like an exaggeration or whatever. So what we need and what we should ask for from everyone, from decision makers as well as from our partners, the feedback on what we said. And there it's the same way, the other way around. We have this information giving the feedback, and there again, the same processes take place, and it might be understood something different. And this is an iterative process until one really understands each other. And this is a theory quite old, as you see, from 1988, from psychology, how you communicate. And what does it mean for communicating science result? I think this is independent of the medium used. You have to know the target group always. What do they not know? What do they know? Not to bore them. Are they non-experts or experts? What is the take-home message you want them to take home? You should select the take-home messages carefully, not too much. 3 pieces we can always carry, more is impossible. So that's also for messages. And you should achieve clarity about it, I think. I think you will be much better than I do, because I'm a meteorologist, not a communicator. Tailor the material specific to these take-home messages. And pay attention to your communication. Every person hears, sees, understands text differently, also words differently. Obtain feedback. You're still awake, that's great. Encourage questions, communicate on an equal footing. And this equal footing is especially important if you talk to people you have no clue of what you're talking about. You really have to go and explain at their level and take them as an equal partner, not as a person below you because this person doesn't know about it. And if you are not yourself in presenting, then everyone will realize that. So for scientific research, we are in this little bubble there. Scientific research tailored in the preparation of scientific research for target group. And as a target group, we mainly see scientists. We use scientific communications. And we hope that the executive directly implements what we found in our publications. And this is not the way. We can make talks, leaflets, brochures, interviews, social media, and then distribute it to people, to politicians, to economy people, to industry, to NGOs, to scientists, and still we are not successful. Because what we have to have is this, we need to find politicians, or we have to directly have people acting. So we vote, that's important. Everyone should vote, I think. And take the chance to choose the right ones. And also the politicians are, of course, influenced by several of these non-political groups from economy, from industry, we all know that, from the NGOs, but also from us scientists. And they are the only ones, at least in Germany, to be allowed to make laws for Germany. There might be other countries, but for our country, it is like that. And they have the laws and the regulations, and the executive with implementing something can only act on that. They can't act on my great ideas. They are not allowed to. They have to act on laws and regulations. And if we are lucky, they tell us what they need. And this feeds back to the scientists, and we can do better. And another way of communication, which I can tell you since more than 30 years, is the data preparation that goes into standards. These standards are used for instance, for the size of the screen, or how the batteries should look like. This is a standard system inside. And it's also for the environmental regulations. There are lots of them which are found in standards. And in these standards, since ages, there are more users for looking at no now because they're going see you. Okay, what could the yes, okay. So and these standards are they not only developed by scientists, they are involving all these green groups. So there could be NGOs, there are sometimes politicians involved, but rarely. There are people from industry involved and which have some economic interests also, and there are the so-named interested parties involved. So not everyone is interested in all the GARD standards, but several groups show up. And it's the idea there is to find a balance between the different interests and have this kind of what these days named co-production already in the standards. And this then can be provided to be taken as a part in a regulation, for instance. But the decision is still on the politicians to use it and not on us. And then it can go again to the implementation. And there we have the force power, that's the judicial power. If something is really not legal, they will tell you what we did wrong. So, coming to standards we developed at the Engineering Association, there we have a co-production, as I said, in all interested parties are involved. We develop in our native language, which is German, and that's true for other standards as well, because it's not only in Germany, it's in all countries, and there are European standards and international standards like ISO, and the draft is done by a working group. And then, which is similar to a scientific publication, we have a public review process. This public review process normally takes about a year, and you get lots of feedbacks, and everyone can say a word on it or can have a word on it. And then there's a consideration of the review objections and the revised version provided. And if needed, if there are severe objections, then a second review is done, as with the publication. Takes just longer. Then the event is finalized, it's translated to English, and then the publication comes, and there is the regular review every 5 years to update it. It includes the state of science in the case of environmental standards in the VDI. It considers aspects of climate change. That's new. We introduced that only last year because it lasts some time. So we take up now climate change because the standardized objects sometimes are used for the next 50 years. And so we have to consider climate change. We can't just say, oh, it will be okay. Yeah, and it's not fast. It takes 4 to 6 years until this is implemented. And this is just on the right-hand side, a sketch on how we do it. That's an example for a standard on local cooled air, which was in a draft in March, is now in the review process and will probably be published in end of this year and will then be open for next year. Finalization and publication in 2025. As I said, it's very time-consuming. It's already time-consuming to come to a consensus between these different opinions in co-production, but everyone who has ever tried co-production knows that. And then it takes time. But the final product then, I think that's a big advantage, is accepted by the community and tailored to the specific tasks which are specified in the standard, and the standards also tell the limitations of using this. And it can hopefully be understood by non-experts. Sometimes this is not the case, and then they complain once it open, and then you have to change it in the next update. And what is also good is that it's trustworthy source. So I think it's also relevant, especially if it's used for adaptation measures, for instance. One example, I think, has everyone heard my talk before? And I don't have to repeat it. It's about environmental meteorology in that group, urban development in view of climate change, that there are recommendations given and suitable measures for adapting urban areas to climate change. It also points out the need of framework for the implementation in urban planning and gives advice for a climate-friendly urban planning, considering the city's function is attractive, should be and remain an attractive place to live and work. And we didn't consider up to now the variability of the outside and of shade and so on. That's something new to him. We had it out in 2020 and are already working on the update because there was so much progress in the science field here in the past years. So it would only be next year we should start, but we already started this year. So an example for a recommendation document, which is not a standard, that is on high resolution atmospheric modeling for assessed urban temperatures. That was published this year and was done on demand because there were so many studies on urban climate done, and several studies lacked the robustness one should have to base decisions and costly adaptations with that on it. So we wrote this document. It's only internally reviewed, which is an advantage because it's fast. But the disadvantage is not all the outsiders who apply it were involved. So it's no co-production in this case. It works that we have a team of experts. That's a method. And they summarize the current knowledge, provide recommendations for actions, and internal objection procedure, as I said, and no co-production, which is not so good. But we want to move into this either by including parts of this in the other standards we update right now, or if we think it's worth to have a separate standard, then we will have that separately, but it's not decided up to now. First, we wait a little bit how it's used. Up to now, it's very much asked for. So to conclude, so coming back to that simple graphics I had at the beginning, even that might need detailed information for the audience to understand and properly use it. And you should always be you, whatever you do. Ask for feedback and ensure the intended content is received. There exist many, many ways of knowledge transfer. Standards have long been developed in co-production, and I think that's a very good way to do it. And in this case, it's really long. The meteorology since 1957 does it. Yeah, standards exist for the assessment of thermal effects in urban areas, and they provide hints for assessing local to mesoscale influences for urban development and much more. Also standards on all the thermal indices, where Andreas was much involved in. So whatever you want, you will find it. Thank you.